Welcome to the 22nd century, where energy is no longer a commodity but a seamlessly integrated part of life. From floating transport systems powered by electrostatic levitation to quantum communication networks, electrostatic potential has evolved from a theoretical construct to the backbone of technological advancement. But how did we get here? Let's travel back in time to understand the fundamental concept of electrostatic potential and how its inheritance has shaped the world we live in today. In simple terms, electrostatic potential is the potential energy per unit charge at a point in an electric field. Mathematically, it is given by V equals the work done in bringing a unit positive charge from infinity to that point, divided by the charge. In the 21st century, electrostatic potential was mostly confined to theoretical physics and electronics. It was crucial in designing capacitors, batteries, and semiconductor devices. The focus was on controlling charge flow in circuits, ensuring stable energy transmission. In the 22nd century, advancements in electrostatic potential have truly transformed our world. We now use it for contactless energy transfer, enabling wireless power grids, high-voltage electrostatic fields, power floating cities, and autonomous vehicles. And get this, energy barriers protect data transfer in quantum encryption, revolutionizing cybersecurity. Let's take a look at floating transport systems. Back in the 21st century, maglev, or magnetic levitation, trains were considered an advanced mode of transport. However, they relied on superconducting magnets and required immense energy. Fast forward to today, in the 22nd century, we harness electrostatic potential for a much more efficient system. Vehicles are charged with controlled electrostatic fields, repelling them from the ground and allowing them to hover effortlessly. Let's take a look at floating transport systems. Back in the 21st century, maglev, or magnetic levitation, trains were considered an advanced mode of transport. However, they relied on superconducting magnets and required immense energy. Fast forward to today, in the 22nd century, we harness electrostatic potential for a much more efficient system. Vehicles are charged with controlled electrostatic fields, repelling them from the ground and allowing them to hover effortlessly. Case Study 2. Wireless energy transfer. Back in the 21st century, wireless charging pads for phones and electric vehicles were, well, considered a luxury, but they had limitations: short range, high energy loss, and inefficiency. Today, using advanced electrostatic field control, homes, vehicles, and even wearable technology are powered without any physical connection. The inheritance of electrostatic potential from the 21st to the 22nd century. First, in the 21st century, it was used in capacitors, batteries, and lightning arresters. Then, by the late 21st century, wireless charging for gadgets became mainstream. Moving into the early 22nd century, electrostatic energy was harnessed for long-range transmission. By the mid-22nd century, entire cities transitioned to electrostatic power grids. And now electrostatic potential controls everything from transportation to security and medical implants. As we advance further, electrostatic potential might hold the key to interstellar travel. By manipulating planetary electrostatic fields, we could develop propulsion systems that defy conventional rocket physics. Imagine spacecraft utilizing naturally occurring electrostatic potential differences between planets, making space travel more energy efficient and sustainable. Electrostatic potential, once confined to textbooks, has evolved into one of the most powerful forces shaping our daily lives in the 22nd century. As we look forward, it is not just a concept, it is the foundation upon which our civilization now thrives. And so, as you step into this future, remember, every spark of energy, every charge in the air, is a testament to the power of electrostatic potential, a force that has not only been inherited from the past, but transformed to define the future.